Ladies and gentlemen, this is Work and Power and correlates with Chapter 11.1 in your textbook. Your key concepts for this video are, what is and is not work? How do we calculate work? And what's the SI unit? What is power? And how do we calculate power and its SI unit? So let's talk about what is and is not work. You may have gone home and said, oh, I have so much work to do. I've got to write this essay, then I have to read this chapter, then I have to do all these math problems. Yeah, according to science, most of those things aren't actually work. Parts of it might be, but you're not really doing work. Because in science, work is when a force moves an object in the same direction as the force. So if I'm pushing a box and the box moves in the direction that I'm pushing it, I've done work. But this little cartoon guy here, he's pushing on that wall, but that wall's not moving. If there is no motion happening, there's no work going on. No matter how hard he pushes, if that wall doesn't move, he may be exhausted, but he has not done any work. Another way not to do work, even though it feels like you are, is carrying things. I'm a scuba diver, and I used to have to put on this jacket thing. It's called a BCD, and these tanks, they're really heavy. So you'd put on your BCD and your jacket, and you'd stand up. When you stand up, you're applying an upward force, and the jacket moves up with you. That is work. But when I'm walking, I'm still applying that upward force because the tank and the jacket are staying up, but I'm moving forward. The motion is forward, but the force is up. So carrying really heavy objects, that's not work either because the motion and the force are not in the same direction. So let's talk about how to calculate work. Work is simply force times distance. We measure the unit in joules, and when we talk about energy later, you'll also learn that energy is measured in joules because work is simply showing the amount of energy being used. It's also sometimes called a Newton meter instead of joules. So comparing this sheet of paper compared to these books, this has much less mass, so it requires less force to move. When you use less force for the same distance, you're doing less work. Here, that stack of books, if I wanted to move it the same distance across the desk as that paper, it would take more force, so I would need to do more work. And yes, there is a handy-dandy triangle to help you move your variables around in this equation. So if you want to find force, cover force, work over distance. If you want to find distance, you do work divided by force. And if you wanted to find your work, like we have here, you do force times distance. So let's try this out. To calculate work, if it takes 40 newtons of force to lift your backpack 1.5 meters off the floor, how much work are you doing? So whenever you come across a work problem, your very first step is to think, is the force and the motion in the same direction? In this case, here's my image of it, I'm applying a 40 Newton force up, and my bag is moving up. So in this case, yes, it is in the same direction. So I simply need to plug in my numbers. 40 newtons is my force, 1.5 meters is my distance, and I solve and I get work of 60 joules to lift that backpack off the ground. So now let's talk about power. Power is simply the rate at which work is being done. Remember, when you see the word rate in science, you know that it's something over time. In this case, it's how much work is being completed per unit of time. Think back to 6th grade and that water field trip that I made you do. And you had to go down to the creek, fill up a little bucket with water, and then power walk it back to your big bin and try and do that as fast as possible. Now, some of you walked slowly with that full bucket of water because you didn't want to spill. Others of you walked very, very quickly with that bucket of water. Those of you that were walking quickly were using more power to do the same amount of work, whereas those who were walking slower used less power because the force needed for this whole amount was the same, but one of you went faster than the other. So how do we calculate power? Power is simply work divided by time, or you could even plug in the work equation here and do force times distance divided by time. Power is measured in watts. It's also sometimes called joules per second or a joule per second because work is joules and time is seconds. So let's try this out. if a person pulling a sled for 120 seconds does 2,000 joules of work, how much power are they using? So we plug in our equation. 2,000 joules for our work divided by 120 seconds for our time gives us 17 watts. And yes, there's a triangle for this as well. Power goes on the bottom, work goes on the top, and time goes over here. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.